I also started the recording. We will be sharing with you the recording as well, so you could listen it. So okay, let's start. At first, what is continuous integration? Why we need something like continuous integration? It's because it's a software development strategy that increases the speed of development that we are doing, and we need it because nowadays most of the applications has got small components. Most of us are working with microservices or technologies like that, and the biggest problem while programming as a team, as a member of a team, is breaking your dependencies or breaking your colleagues' codes. So somehow you need to manage your dependencies. You need to manage your deployments, and that's how continuous integration and Jenkins begin. It began as a development in some microsystems, and the reason was to manage the development project deployments. So basically, in continuous integration, developers continue commit code in small increments. Most of us are doing daily commits, so we will have the latest daily snapshot at the end of the day. And most of these commits are automatically built and tested before merged to the shared repository. And this allows us to be sure that we have the most recent code in our repository, and it's merged correctly, because merging the repository is the biggest problem. So basically, it depends on every developer commits daily to shared mainline code repository, and every commit triggers an automated build and test of code base. So if the build or any of this fails, then it could be repaired quickly. Because if I did a mistake, or if somehow something unexpected happened, since we didn't merge it to the repository yet, it is very easy to get your code and fix it and then deploy it correctly. So that's what we need, continuous integration. Another point is we have more than one environment. Most of us has got lots of environments like production and development environments. So continuous integration also allows us to manage those environments and build our code with environmental dependencies. So it improves the developer productivity, and because it helps your team to be more productive by freeing developers from manual tasks and encourage them behaviors that help reduce the number of the errors and bugs released to the customers. And it allows us to find and address bugs quicker. With more frequent testing, your team can discover and address bugs earlier before they grow into larger problems later. And there are some components that we could use with Jenkins, like SonarQube, which will do this for us automatically, which allows us to define some code quality criteria, and which force developers to write better code. And it allows us to deliver updates faster, because it allows us to update to the customer faster and more frequently, since we are frequently updating the database, our code. we will have a more recent code base every time. So it depends on several important principles and practices. One of them is maintaining a single source repository. Lots of developers are using single source single resource, single source repository, and it allows us to automate the build. So it will be automatically build it. For example, if you're a Java developer, most of the Java projects we have got, especially in Spring projects, we have got application.properties or application.yaml, and in these configuration files we have the environmental variables or project configuration files which are related to the project, and continuous integration could help us to put them in Jenkins or any other CI/CD server, so that we could just deploy our code, and depends on the environment, depends on the branch that we are committing, it could do the related jobs, and it makes your build self-testing, because we will be testing our code every time. Every developer is testing their code every time, so it's much more easier to manage and much more easier to write bug-free code. And every commit should build on an integration machine. So before we put it to development or test or production environments, we are committing our code to integration machine. We are migrating our code to in there, and we are merging it, and then we are moving our code to the next stage. So by doing that, we always have the most current code, most up to date, and bug-free code. It also keep the build fast, because, like I thought, it is automized. We don't have to deal with environment variables or most of the configurations. It's automatically done by the continuous integration server. Test a clone of production environments, because basically all of our environments must be same with production. So basically, without releasing our code to production, we will be aware of what will be done. Also, we have got strategies like blue-green, so we could do that without any failure. And it makes it easy for everyone to get the latest executable version, because we always have the latest executable version, since everyone is committing to the same code base. And everyone can see what is happening. Basically, you have to pull your repository and make your changes and push your repository. You need to refresh it, and you will see that who changed which part of the application. That's very easy to see it. And it automates the deployment. So it does the deployment job for you. How does continuous integration works? So basically, with continuous integration, like we thought, developers frequently commit to a shared repository using a version control system like Git. And as you could see here, this is our source control repository. What we are doing is then building our code and then staging it. So after we build our code and run our unit tests, we are deploying it to test environment or development environment, and then run integration tests. And if there are any tests we need to run, we are running them, and then we are transferring it to production environment. So there are stages while we are running our continuous integration. So prior to each commit, developers may choose to run local unit tests on their code if they want extra verification layer. And it automatically builds and runs tests for us. So by talking about CI/CD, we are talking about continuous delivery and continuous deployment. How it works is how to do it. So basically, developers check out their code into their private workspaces, your local environment, or it might be a Docker instance if we are working in that Docker. And when you finish your coding, you need to commit your changes to the repository. CI server monitors that repository and checks out the changes when they occur. So basically, when we commit, it understands that there is a new commit and then takes action. So CI server builds the system and runs unit and integration tests. This might not be automatic. So this is something that we could decide if we want to automatically build or if we want to manually do it. CI server then releases deployable artifacts for testing and then assigns a build label to that version, and it just builds it. And then it informs the team for successful build. Mostly it informs you by sending email. So you will get an email about if it is if the build is successful or failed. And if it is failed, you could also see the reasons that causing this fail as well. And that's not just you, everyone in your team could see it. So it's very easy to take action against it. The team fixes the issue and at the earliest opportunity. So who could fix the issue, then taking immediate action. And then it continues to continually integrate and test through the project. So here is our code. When we commit, it also compiles the related code, and then it builds. It runs the unit tests. It runs the integration tests. This is the continuous integration part of it. Sorry. And then in next stage, we are reviewing our code. In continuous deployment part, we are reviewing our code, do our staging. So there could be more than one stages. There might be development state, there might be test state, and there could be some other stages. There's lots of strategies for that. And then at last, it will go to the production. So basically, continuous integration automates the building and testing of your software, and continuous deployment is allow you to deploy your software to other staging environment and production. So it allows you to deploy your software easily, and it allows you to review your code, because all of these, ideally, all of these environments, both staging and production environments, must have the same code base. So in continuous integration, we have got two options. I mean, we could deliver manually, so we could deploy it to production manually, or we could do automatic deployment, which means when it runs the tests, it will automatically deploy it. So which means when I commit my code, CI/CD server will automatically detect it, builds, runs the unit tests, integration tests, and then trigger the deployment procedure automatically. Otherwise, I could do it manually. For example, in the company that I'm working for right now as a contractor, we prefer to deliver it manually because for most of the projects, we don't want automatic deployment. It's better to, sometimes at least, it's better to manage it manually. So why do we need it? Why do we want to use it? Many organizations deploy new release of code in production takes a huge amount of record, and CI/CD brings continuity where quality checks and bugs are checked frequently. For example, again, in the company that I was working for, I joined them nearly 2 years ago, and they were not using Jenkins before. So for each of our staging environments, I think we had got 3 staging environments. We had to create the configuration files in the project. We need to trigger the related deployment procedure, configuration and build and deployment procedure for each staging environment. So this also allows you to deploy your code to wrong stage as well, because mistakenly you could easily commit your code test environment rather than development environment, and when there is a next release to production, it might go to production if it gets unnoticed. So it allows you to overcome these kinds of problems as well. As a result, CI/CD brings the following benefits. Updates can be released faster, because basically you are continuously updating your code, and it gives you higher productivity, and it gives you higher sustainability because it's automated. So everything is done automatically. What you need to do is just to trigger your continuous integration or continuous deployment job through Jenkins. Or you could also automate it as well. So AWS has got some components as well for continuous integration. One of them is AWS CodePipeline. So AWS CodePipeline is fully managed continuous delivery service, which helps you to automate your release pipelines, and it gets your source, it builds it, tests it, and sends it to staging and production environment. It also integrates with Jenkins as well. So it allows you to do rapid delivery, automating your build. For example, you are using GitHub. When you build it, or when you made a change in your GitHub repository, it could automatically understand it, and it could automatically trigger your build procedure and do everything for you. And it is fully managed, so you don't need to manage the service. You don't need to you don't need to take security actions or other things. It's fully managed. You are just using it, and it allows configurable workflow. So basically, you can use it with CloudFormation and AWS Seertech, and you could configure its workflow. Also, they have got Code Build. Code Build is same. I mean, CodePipeline was doing continuous delivery service, and Code Build is doing it for compiling the code and run tests and create your software packages and make them to deploy. So you can use Code Build as a worker node for your existing Jenkins server, and you can scale it up or down. So if you are building much more components, then you can use more code build instances. When you are not using it, it could scale down, because otherwise maybe you need to use EC2 instances, etc. for it. You might have. You can bring your own build tools, so you could use it basically with everything. And well, basically it's fully managed, so it could automate software development services, the software developments to instant services like Amazon EC2, Fargate, Lambda. So basically you could use it with anything within AWS, and it constantly deploy your application. It also creates push notifications, so you will be informed that there is a new code build, and if you want to take any action, you could do that. And it's platform and language and this agnostic, so it could work with anything. So let's take a look at Jenkins Build Architecture. So Jenkins master can operate itself both managing and build environments. So this is our Jenkins master server, and we could have more than one Jenkins slaves. Today we won't be using any Jenkins slaves, but basically we could use as many Jenkins slaves as we want, and it could be of any operating system. So one Jenkins slave we could use Windows, one Jenkins slave we could use Linux, and for another one we could use macOS. This gives us the flexibility to build and deploy our code to various operating systems and various environments. And these slaves are communicating with Jenkins server by using TCP/IP protocol. Master is responsible for pulling the code from the repository, but ideally it is not processing it. Once it gets it from the repository, it is bypassing it to its slave servers, and slave servers are doing the job and turning the result to the master server. So we talked about master and slave servers. Here is a calculation. Basically, you could use this calculation to calculate how many servers that you need. For example, for your number of jobs, it depends on how many developers. There is a constant ratio. Also, for number of jobs, there is a constant ratio that you could find the number of masters. And again, same, there is a constant to find the number of the executors. So the slaves are the same thing. If you are not using slaves, then basically for master, you could also define how many executors you will run. You can tell each executor is a thread. So one of the important features of Jenkins is its plugins. It has got lots of plugins that you could use it, and they mostly change the functionality of Jenkins. They have got good add-ons. For example, there is Git plugin, Maven and Gradle plugins, and GitHub plugins. There is also SonarQube plugin. That's one of my favorites. I mean, sometimes it gives you hard time because it has got lots of code-based practices, etc. So possibly until you get used to it, maybe you may need to review your code a few times before sending it for deployment. And there are template plugins, monitoring plugins, validating plugins. So there are lots of plugins that you could use. And Jenkins Pipeline is the most important thing in Jenkins, because we are running our processes through Jenkins pipelines. So a pipeline is a user-defined model of a CD pipeline, so continuous deployment. It depends on nodes, stages, and steps. So a node is a machine which is part of Jenkins environment that is capable of executing a pipeline. So it could be an executor, or it could be a Jenkins slave server. It could be both. We could tell Jenkins which node we want this to run, or we could arrange our nodes to run specific pipelines. We have this flexibility. And there are stages. So mostly there are build, test, and deploy stages as well. And for each step, we have got, for each stage, we have got steps. Steps are the actions that we need to take. So here is a, hello, Melissa. Here is a diagram about how it works through development to production. So if we take a look at it, when we commit it, we need the repo and branch name, and then workflow starts. So in first stage, we are checking out our code. We are getting the dependent repositories as well. And then we are going to build stage, build and launch stage. So at this stage, we are building our Docker container, and then we are building our code as well, our modules. So after every module is compiled and ready to be launched and packed to the Docker container, we are going to the next stage. In next stage, we are testing our code. So we are running our integration tests and smoke tests and any other tests, and we will get our test results. If it is successful, then we are going to the deploy stage. In this deploy stage, like I told, we could also do staging as well. I mean, we could deploy it to test environments, development environment, or production environment. We could decide it in here as well. And after the deploy stage, we are building the report and the workflow events. So these are the stages. These are the jobs we are running. These are the steps of the job. And this whole process is ideally running on a node. Like I thought, we could decide which node it will run, or we may leave it to Jenkins as well. So there are a few best practices that we could apply. One of them is always secure your Jenkins, because by default, it is not secured. It allows connections, so it's a good idea to always secure your Jenkins environment. And in larger systems, don't build on master, because basically when you build on master, you have the option, you might break your code. So as a best practice, it's better to use master as read-only and escalate the jobs, the steps to the worker nodes. For example, in our production environment, in our CI/CD environment, our master is read-only, and as a developer, I need to tell our DevOps that I will do a deployment. So they are starting the test instances. I cannot be able to start test nodes, at least for production. For test, there is no problem, but for production, the DevOps must start the test, start the slave nodes, so that I can deploy my code to production. So we have got two levels of security here. And it's also a good idea to back up your Jenkins home regularly, because anything could happen. And limit your project names. Use file fingerprinting to manage dependencies. So there could be dependencies with same name, etc., etc., etc. If you use file fingerprinting, they will be unique. You will be sure about it. Use clean builds, which are built fully from the source code control. So always get the latest code from the source code control. You could also integrate it with Jira. So, like I told, it is sending mails about if it is successful or if it fails for some reason, etc. But if you integrate it with Jira, also you will get this report in Jira environment. So you could be able to log it, see it, and do whatever with this information. And it's always configure your job to generate trend reports and automated testing when running a Java build. So you will see what's going on. Another important point is setting up Jenkins on the partition that has the most free space, because it really takes space. And archive unused jobs before removing them, because you may think that it is unused, but it might be used. Maybe rarely, but it might be used. So it's a good idea to archive them before removing. And set up a different job project for each maintenance or deployment branch you create, so that basically you will be able to manually configure them, and you won't be doing something unintentionally, because otherwise you may do it. It's very possible to do mistakes while you are doing copy paste. And it is also a good idea to prevent resource connection in jobs that are running in parallel. Avoid scheduling all jobs to start at the same time. So you could use sleep or some other things for it. Set up email notifications mapping to all developers in the project, so that everyone on the team has his pulse. So everyone knows what's going on in the project. And take steps to ensure failures are reported as soon as possible, because this is one of the reasons that we are doing it. We need to ensure that we know the failures as soon as possible, so that we could take appreciate actions. Also, write jobs to your maintenance for your maintenance tasks, such as cleaning operations, to avoid full disk problems. So basically, it's not a good idea to leave everything behind. It's a good idea to automate everything, even the cleanups. So you will be saving this space. Take label or baseline the code base after successful build. This is also important because you may always want to turn back to a specific label or specific tag, especially in my current contract. Again, when we are sending something to production environments, we have to take the commit, and then we need to give that tag name to our team so that they could evaluate it and they could approve it. We have got an approval committee, so they need to approve it, and we need to deploy the code base with that tag only, because we are just approved for that tag, for just that change. Here also you can find some more examples. So these were my slides. So this is my AWS environment. I created a CodeDeploy. I created a EC2 instance. By the way, I will be giving you, let me see if there is, where is it? Sorry, 1 minute. Everything that I did in this example is documented. So I will be sharing it with you guys. So basically you could run this example from scratch. AWS once you register, giving you 6 months of free usage on some services. There are some quotas, but you could use this example for free. It's not spending lots of resources. So basically, let me tell you, we have a security group. We have a security group, and in this security group, I allowed HTTP port to be accessible from my IP, and 8080 to be accessible from my IP, because Jenkins is by default running from 8080, and I allowed 8000. This is where my application is running. I also allowed 3000 as well, but I'm not sure I have to do it because basically this is the port that Docker is using. So Docker is exposing this port to this port. So only this port will need to be accessible from external IPs. And I have a rule for SSH. So by default, if you don't define anything in your security config, then your server won't be accessible from outside. But I want my application to be accessible, at least part of my application will be accessible from outside, so that I could connect it. And I have got some I am definitions as well. I have a user. I set to give a user, and I have a role. I've created a role. My role is code deploy role, and I will show you about it. And I've got policies. Sorry. So this is the service role policy. This allows my user. I mean, this allows some priorities to the user that I assign it. So it allows us, the user could describe an EC2 instance, so it could get its details, and it could do some tasks with auto scaling. So this is my policy, and also I have this role. For this role, I also give, and I'm using also another policy which allows the user could access to S3. So the user could be able to get and list from S3 instances. And it is also using it also has the service role policy. And I have got trust relationships. This trust relationships is required because I'm using code deploy, and I could list any code deploy regions in here. When you are doing this example from scratch, you could change it, because basically I mistakenly create my EC2 instance in America and my S3 is in Europe. So you might want to use everything in Europe. So you don't need this Southeast, etc. Regions in service definition. They are not required. And also, after this stage, after I created the S3 role, then I'm creating the security group that I showed you. I didn't use public IP here. I just limit my server, my EC2 instance with my IP. So I suggest to do that as well. And then I'm creating an EC2 instance. While creating the EC2 instance, I'm choosing Amazon Machine Image 1, the old version of it. And then assigning the role, assigning this role. This is important because I want my instance could be accessible from code deploy. So let me launch an instance. I won't launch, but this is the instance that this is the AMI that I am choosing. You could use any other AMI, by the way. I just use this one. And next year, because this is the only free tier eligible. version. Only one instance I'm choosing. Default storage is also enough for me. Also, I'm using a tag here. I'm using it because it's always a good idea. CodeDeploy 2, because then I could basically access it by using CodeDeploy 2 rather than the server IP, etc. And then I'm assigning the security group. I'm choosing the security group, and if I click where we run launch, it will launch my instance. That's how I created my EC2 instance. Then I'm basically, by using SSH, I'm connecting to my server. This is my local. I downloaded this PM file. When you are creating your large instance, it will ask you to create a password file. This is the password file. You can download it, and I suggest you to download it because it will be the file that you will be using. So basically, I need to change this name. An IP address might be wrong, maybe. Yes. So here, I connected to my instance. And then there are some steps that I need to do. One of them is copying AWS CodeDeploy from the S3 repository, and then installing it. And then I need to create a S3 bucket. So I need to create a CodeDeploy service as well. Creating S3 buckets is easy. You just need to tell create buckets and then give it a name. And you don't need to do much more things. But for CodeDeploy, okay. Here. For CodeDeploy, you have to define these parameters that is written in here. We will be using EC2 instance, not ECS or something else, and we need to use the CodeDeploy role as well because we created this role for it. And then we are installing Docker. We are installing Jenkins. While we are installing Jenkins, after we install Jenkins, we are giving appropriate form configuration groups for it. We are creating the Linux groups. We are configuring our Java. And at last, we are starting our services. After we started our service, we could be able to join our Jenkins. So this is my Jenkins environment. when you first join it, I mean, when you first load this page, it will ask you a password. So this was my initial password. You can get this initial password from, from this location. I think I'm connecting to wrong server. Okay. See if I can see. I think it is deleting later on. So this is the file that you need to read your password, and then it's something like this one, and then you need to copy paste it to where prompted, and you will be introduced a few questions. One of the questions is if you want to install suggested plugins. It's a good idea to install the suggested plugins for now, at least for this example. But for a production environment or professional environment, it's better to manage your own plugins because less is better. And then I am installing these plugins: Pipeline, AWS Steps, CodeDeploy, Code Pipeline, Code Build, and AWS EC2, as well as Blue Ocean. So to install plugins, you need to go to Manage Jenkins and then Manage Plugins. In Manage Plugins, you could see your available plugins. I think it will give you all this. No, it's not. Installed ones, it gives you the complete list. And if you want, you could basically search your plugin. So you need to search these plugins and install them. So these plugins are for to connect AWS and run code deploy, code pipeline, etc. And this one is for Blue Ocean. Blue Ocean is a nice utility to let you see your pipeline, how your pipeline is running. After this step, you need to you need to obtain your EC2 private key and configure your cloud. So basically, sorry. Okay, you need to do a few things more. You need to secure your Jenkins environment here, and you need to put your AWS key in here. You need to add your AWS key, and it is easy to add it. Just add credentials, and you need to write your username and password, or for AWS credentials, you need to write your access key ID and secret access ID, secret access key. You will be having it from AWS. You could check the AWS documentation how you can get it. It's not hard. And basically, when you are creating your user, it is giving it to you, so you need to copy paste. Here is mine's, but I will delete them as well. I mean, I will delete the account, so it's not very important. After doing this, we need to configure the cloud, and then we need to access it to GitHub. So in GitHub, we also need to do some more things. I'm checking if there are some things that's I missed to tell. There is nothing. This is okay. Okay. This is our master instance, as you see, and these are our idle build executors. I'm running only two executors for it. And here is my Amazon credentials. If you want to add new, this is same. You need to choose Amazon EC2 instance and then enter your credentials. You could add it from this menu. This is same like the other one. So you need to choose them. And at the end, it will be like this. This is required because we are using AWS EC2 instance, so it allows us to connect to EC2 instance. And this is the sample application that I am using. In this sample application, I need to do a few things to make it running. One of the things is, let's see. Sorry. In project settings, at first I need to create where was it? I need to create user token, and then I need to, if I'm using SSH, I could basically create a SSH key in my local environment and then put it to here as well. Checking it. Token must be here, but I couldn't find it. By the way, we are not using it. But you need to create your token if you want to integrate it more closely. Okay. So here is my user. And my repositories. This is the repository that I will be using. And in these settings, I need to define a webhook this is the webhook that I'm using. You need to put this slash, this and slash here. If you don't, it's not working. In content type, it must be application JSON, and then you can add the webhook. And this is the URL that you need to use. This is standard, so you don't need to do anything with it. You just need to write your server IP and port and GitHub webhook, but with the trailing slash. And it is written in here as well. Then you need to create the Jenkins file. So this Jenkins file is the important thing that you are doing. So in the code repository, it is already in there. So you don't need to create it, but if you are doing something from scratch, you have to do it. So let's take a look. This pipeline, and then what we need to do is to execute the pipeline. So like I told in our slides, we have got a pipeline, and each pipeline has got its stages, and each stage has got steps. So as you see, these are my stages: install packages, test and build, deployment, and then staging or production. Inside deployment, and these two will run in parallel. So they won't wait each other. They will run in parallel consequently. So agent allows me to define an environment. So what I'm doing is I'm creating a Docker instance with this image, and this image has got the node server, and I am exposing port 3000 to 8000. That's what I'm doing. And then I am defining my stages. First stage is install packages, and in install packages, I only have got only one step. I'm running a npm install. That's what I'm doing. And then I'm moving forward to test and build stage. In this stage, run tests and create build artifacts will be running in parallel. One of them might be end sooner or later from the other. So I've got two scripts. One of them is test sh, and then I am running npm run build in parallel. So I'm building my code, and then I'm testing my code. I will show what is in test sh. Then I'm going to the deployment stage. So this is the last stage. In deployment stage, I've got two stages: staging and production. In staging, this is my test environment. And I'm checking one thing: if my branch is staging. So if my branch is not staging, I'm not running the steps, and I'm quitting. So I'm not running anything. In production stage, if my branch is master, it's okay. I will run the steps. But if it is in production stage, but my branch is not master, I won't run anything. So let's say if we have a test branch, this script won't run anything in deployment stage. it will bypass both of them. And in deployment state, here are our steps. Basically, we are giving S3 delete and upload rights, and then we are mailing to our team. This is just mailing to my mail address about production build, and there is a new deployment in production. It is running the scripts to deliver for development SH, and then it sleeps 100 seconds before it kills. So it allows me 100 seconds for me to show my application. In production, I'm nearly doing the same thing, but I've got the delete in here. S3, I'm doing a S3 delete operation. And then I'm running the same shell script. And for environment, I've got some definitions. These are my environment variables. So CI is true, home, and npm config catch. So what I need to do is to run new item. This is a multi-branch pipeline. I need to give a name for it. And then I need to configure it. I need to, for example, choose my project. Credentials are okay. And then build my configuration. For building my configuration, I could also use Jenkins file or something else. This is for creating the source. This is for creating the pipeline. And then I need to create my Jenkins file. Here is the pipeline that I was creating. Let's see if it will work. This is, by the way, Blue Ocean. It fails at last time. That's because I've got quota problem. But when you run it, it runs like this. So it tells you, I did this job. I run npm install. I run tests. There was no test specified, so didn't do anything. I do my npm build. And then in staging, I delete file from S3, copy file to S3, and production build, and then run this deliver for development SH. So let's try to rerun this. Okay, please. This will fix it. Okay, let's try to run the other one. This is the master one. I don't think it will run either, but let's try it. Seems like I still have got a problem. It's not working. Well, you could try it on your own. If you follow the steps, it will be working. Okay, let's make it. Let me see, the original one shows me. Here you could see the console output. Yeah, this is why it's not working. Okay, so sorry about it. That's because my GitHub is exhausted. Okay, so thanks for listening to me. Are there any questions that you want to ask? I think there's no questions. Okay, then thank you for joining. If you are interested with it, we have a Jenkins workshop on this Saturday as well, and we will be doing a Jenkins example, which we will use lots of these things in AWS, and we will have a few test instances, so it will be a good example to understand about sorry, to understand about how Jenkins is working. Yes, you will get the slides. You will have access to this video as well, and you will have access to example file. I mean the guide file. So you could run the same example on your own. And if you have got any questions, you could always ask to us. And like I told, if you want to get to know more about it, we have a workshop on Saturday. You could just attend it. Thanks for joining. Thank you, Eddie. Okay, good night, everyone. Thank you very much. We will be sharing you all of the resources that we have. Thank you.